Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called SVS number 453, S-Doku by Richard. And here are the rules. Apply classic Sudoku rules, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in... Well, actually, let's do it this way. In every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. In addition, the 3 rows and 3 columns of 3 3x3 blocks contain each 9 gray cells in which the digits 1 through 9 have to appear exactly once too. For example, row 3 column 1, row 2 column 2, row 1 column 3 through 7, row 2 column 8, and row 3 column 9 is another set of the digits 1 through 9 exactly once each. And that's for every row. So, sorry, for the 9 gray cells in the rows 1 through 3, in the 9 gray cells in the rows 4 through 6, and the 9 gray cells in the rows 7 through 9, as well as for columns 1 through 3, the 9 gray cells, for columns 4 through 6, the 9 gray cells, and for columns 7 through 9, the 9 gray cells, you have to have the digits appear in those gray cells exactly once each. I hope that made sense. It took me a little while when I first read that to try to understand what exactly was going on. Or what not exactly was going on, how that actually worked, but it made sense once I saw the example. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, this digit has to be this digit here. Because these 7 digits are the same for row 5, and this digit can't be that digit, so where is this gray digit? Since these are all unique in this gray set, where is this gray digit going to be? It can only be here. So this A would be here, and similarly this Z has to be appear there. A cannot be in any of these digits here. What can A be, actually? A can be... These 2 digits cannot be the same as these digits here. So these 2 have to be these digits here. And these 2 have to be these digits here. So one of these is an 8, and this cannot be 8. So this must be 8 here. So we can remove the blue from the 8s in this in these columns. So this blue matches that. Same with these and these, right? So this cannot be 8 here. So this 8 sees all of these cells. It sees here, so this must be 8 here. And then this must match this cell here. So we're matching that. Therefore, we have a guaranteed 8 here. We have a guaranteed 8 here. We must have a guaranteed 8 in one of these 5 cells. These 2 digits must match here. Two cannot be here. Cannot be here. Cannot be here. where is it in box 3? It has to be here, right? Because 2, again, cannot be here, cannot be here. It can't match this because this cell has to be one of these 2 digits here in row 1 because it can't match any. This cell can't match any of the other gray cells, so it has to be one of these 2. So therefore, this is a 2 here, which means in row 2, where is a 2? Can't be here because 2 in the box, can't be here because of 2 in the box, so this must be 2 here, and it's 2, 8 as a pair. Where... No, that's not true. Where is 6? Well, that's not... Yeah, okay. Where is 6 in this set of 9 gray cells? Can't be here because it's in the same box. Can't be here because that's a 2. Can't be either of these because they're in the same row. Can't be here because of 6 in the column. So this must be a 6 here. So this is 6, which means 6 has to be one of these 2 digits, obviously. Hmm. 5 can't be here, 5 can't be here, so 5 can't be here in the middle box, so 5 is one of these 2. This digit specifically. So remaining digits in row 2. We have 3, 4, 5, and 9. This cannot be 3. This can't be 3. Okay. Where is the 3 in box 7? Can't be here or here. Can't be the blue because that matches that cell. And there's a 3 there. Can't match the red because it would match one of those. So 3 has to be here. Well, where's 3 in column 2? Can't be here because of 3's in the boxes. Can't be here because it must match one of these 2. And this can't be 3. That's a 6. So it must be this dark cell. So this is 3, which forces the dark cell to be 3 here. That's 3 in the corner. We celebrate because we're getting closer to solving this. That means this can't be 3 here. Where are 4 and 5 then on the gray, in the gray 9 cells in row 1? Cannot be here, so they have to form a set here. So this is 4, 5, this is 4, 5, and this is essentially 4, 5, and 6 as possibilities. So therefore, this 4, 5, 6 triplet eliminates 4, 5, and 6 in the rest of the box. This can't be 4, 5. It's 9. That makes that 7. This 9 eliminates 9 here, so this is 4, 5. That leaves this as 1, 7, 9 remaining in the row 1, which leaves this as a 3 in box 2. That leaves these 2 digits as 1 and 9 in row 3. Okay. Where is 7 in the gray cells? Cannot be here because of 7 in the box. Can't be here because of 7 in the columns. And can't be here because of 7's in the rows. And this is already 8. So this must be 7 here. Which means one of these is a 7. One of these digits are 2. We don't know which. 6 eliminates 6 from these cells. A and Z all see these cells. So what can they be? These can be 2, 4, 5, 6, and 9. But they can't be 2 or 6. So no 2 or 6. No 2 or 6. They also can't be 5, so it forms a 4-9 pair, interestingly enough, because of 5 in this box here. So this is a 4-9 pair, which eliminates 4 and 9 in the rest of the column. This can't be 4, it's 5, which makes this not 5, that's 4. That forces this to be a 4-6 pair here, and the 4-9 pair eliminates 4 from being there, so that's 6, which makes this 4, and that's 5. So that's done for the gray region there. Um, 7 can't be here because of 7 in the column. No 9 because of 9 in the column. This 4 means this can't be 4 here because of this set of 9. So this must be 9, which makes this 4. So the A is 4 here, and this is 9 there. This is 7. 8 cannot be here because of 8 in the 3 columns here. So where is 8 in column 3? Can't be here because of 8's in the boxes. This is filled out. 8 can't be here because of the unique set of 4-9 gray cells in columns 1 through 3. So this must be 8 here. So that's 8. Same with this 8. This can't be 8 here because of the unique gray cells here. We need to have a 7 in the gray cells in columns 7 through 9. And they can't be here. It can't be here. So it must be here. So this is 7. That means we have 1, 3, 5 remaining. And neither of these can be 5. So where's the 5 in the gray cells for column 7 through 9? It must be here. So this is 5, which forces this not to be 3. This is 1, and therefore this is 3 for the 3 for the 9 gray cells in columns 7 through 9. This 5 means this has to be 5 here. That leaves a 2 remaining in column 1. Remaining digits in the gray cells in column 1 through 3. We have 1, 2, 6, and 9. 2 and 9 cannot be here. And 9 can't be here, so this must be 9 here. So this becomes a 7-9 pair. So the blues are fine. This can't be 7 here, so this must be 9, which makes this 7. 9 here eliminates 9 here, so this is 1 and 9. Again, 1 can't be here. This is 2, because 2 cannot be any of these cells here. So this is a 1-6 pair. 6 can't be here because of 6 in the column. So this is 1, this is 6. And the remaining digits in row 5 are 2, 5, and 8. So 5 cannot be here. 5 is here. And this is a 2-8 pair here. Since this is a 2-8 pair here, this 2-8 pair eliminates 8 from being here, so this must be 8 here. Of the remaining digits in box 4, this can't be 5, so this is 5 here, which makes this 7, which leaves this as a 1. And this must be 4 remaining in column 3. 8 here eliminates 8 here, so that's 2 and 8, which eliminates 8 here, so that's 2 and 8. Remaining digits in the gray cells in columns 4 through 6. We have 3, 4, and 6. This can't be 3 or 6 because of 3 or 6 in the column. So this is 4, which leaves this as a 3-6 pair here. This can't be 1 because of 1 in the box. So this must be 1 in row 8, which leaves this as a 4. Okay, how many ones do we have? This one eliminates one here, so it's 7. We're missing a 1 in column 9, so this is 1 there. And we don't know where 1 is of these. 2s. 2 in column 8. This can't be 2 because of 2 in the row, so that leaves just this. So that should be, we have 8, 2, so we know where the last 2 is. It's there. 3s, still kind of up in the air. 4s, we have 8 4s. We know where the last 4 has to be. It has to be here. 5s, I think we should have 9 5s. 1, 2, 3, 4, 5, 6, 7, 8, 9. We do. 6s, we're actually kind of limited on 6s. Except that in row 7, we know the 6 has to be here. That means in box 6, 6 can't be here anymore, so 6 has to be there. And then we don't know about the 6s here. So then 7s, we have 8 7s, so we know where the last 7 has to be. It has to be there. 8s, we have 8 8s. We know where the last 8 is. It's there. 9s. We have in the central box, where can 9 be? Cannot be here or here, so it must be here, which means this can't be 9, that's 1, which means this can't be 1 or 7, that's 9. So now we should have 8 1s. We do. We know where the last one has to be. It has to be here. And then 3s. Where can 3 be in row 6? It must be here, which means this can't be 3. That's 6. This is 3, which leaves this as 6. And, yeah. The logic actually behind this wasn't that easy, but the execution was actually easier than the logic. It was interesting. It was interesting that I felt like the execution of this was pretty easy, but the logic actually wasn't necessarily. Huh. Anytime you have like extra sets, it makes things a little interesting about where things can be restricted and where they can't. So, I don't know. Pretty interesting. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.